Good morning, dear students. We have already seen the image formation for convex lens in light reflection and refraction. And today we are going to see the image formation of concave lenses. Okay. So concave lenses, you know that it is a two curved surface which is there. So that two focus will be there, F1 and F2, which you have seen in the previous videos. Now we are going to see the image formation for concave lenses. So when it comes to image formation, concave lenses, we consider only two positions. Okay. So when it comes to two positions, first position, when the object is placed at infinitive. Infinitive, if the object is placed at infinitive, so what is the thing which is happening over there? That is what we are going to discuss it. Okay. So this is a concave lens. The object is at infinitive so that the light rays comes parallel to the principal axis. You can see here the lights are coming parallel to the principal axis, up and down both. So several rays which will be coming here. When it reaches the optical center, it will get diverged. Diverged means what will happen? It is not converged, it will be diverged. It is going away from each other. It is going away from each other. So that what we consider here is, so it has to go as it is. Okay. So what we have to do, refracted ray, on the back side of the refracted ray, we have to draw a dotted line on the back side. Can you see this dotted line which is drawn on the back side? So similarly on this side also, there is a dotted line which is coming on the back side of the divergent ray. So these two rays meet at a particular point, that is first focus of the concave lens. So this is center of curvature, this is focus. So at this focus, it will be captured. We have already studied the rules for image formation. What is the rules for image formation? As we have seen, if the light ray parallel to the principal axis, after refraction, it passes through the focus. Right? So on the back side of the refracted ray, if we extend, it will be passing through the focus. Okay. So what kind of image which is captured when the object is placed at infinitive? So the image is formed at F1. You can see here the image is formed at F1. It is virtual and erect. Virtual means it is the same side of the object that we can get it. So that it is a virtual, it is not the real one, because dotted line, if we draw it, we consider this as a virtual one. Virtual and erect. If it is a real image, it will be inverted. Because it is a virtual, it is an erect image that we can get it. It is highly diminished. Diminished means small in size. Highly diminished means it is a point size object that we can get it over here. It is a small point size object. Okay. And second position, the object is kept somewhere in the principal axis from optical center. Okay. Somewhere in the principal axis between infinitive to optical center, if we keep an object A and B, where the image will be formed. That is what we are going to discuss the next thing. So, therefore, for all positions of the images on the same size of the object, for example, here the object is kept at a position A and B. One ray goes parallel to the principal axis and it will be refracted. And another ray goes through the optical center without any deviation, it goes as it is. So, where these two rays meet over there, refracted ray, we are drawing a dotted line on the back side. It will meet at F1. So where these two rays meet at a particular point, there the image is formed. Okay. So therefore, all the positions wherever it keeps, the image is on the same side of the object. Image formed at the same object is one side. Image is also formed on the same side. So image is on the same side of an object that we can get it. Second one, it is virtual and erect. This is also erect means it is a straight image, not inverted. It is a virtual image which is captured on the same side of the object. And how the image is looking like? It is like looking like diminished. Diminished means what is the size of the object which is kept over here? A and B. It is a big one. And see the size of the image, it will be small, A and B. So that it is considered as a diminished image. Okay. So next, if you see, it will be given the image formation by concave lenses as a tabulation. In that tabulation, position of the object means it is two position at infinitive and between infinitive and optical center, two positions. Okay, as we have discussed in there, the object is kept at infinitive means what will happen? The image, how it is formed, can you see here? So formed at f1 and virtual and erect image which is found over here. Similarly, here also position of the object is at f1, position of the image is at f1, size of the image is point sized, and nature of the image is virtual and erect. Okay, so and between infinitive and optical center, if we keep it, the position of the image is f1 and o. Position of the image is f1 and o. Okay, 1 minute. Position of the image is f1. Between f1 and optical center, the image is formed. This is the position of the image. Okay, and size of the image is diminished. As you can see here, so the size of the image is diminished, and it is virtual and erect. Okay, it is virtual and erect. So this is the image formation of a concave lenses. We have already seen the image formation of convex lens, and now we have discussed the image formation of a concave lens. Convex lens, concave lens, both that we have seen. Go through these two videos continuously. I'm going to conduct a test on this. I'll inform you when the test will be in the WhatsApp. Okay. Thank you.